Well, I represent in the Multimedia Brazil team. I work directly on this task. And yes, okay. We presented this from MediaEval 2017. And as we know, there is really fast. The goal of this task is to automatically select most interesting video segments or image segments for its both subtasks. Our approach was pretty much alike between both the subtasks. We were focusing more on video and then trying to apply it on the images. And our work this year focused mostly on different fusion techniques for information. These are the available features that was provided by the competition. Most of it are video most of the video features are frame-based features, or consider a low to medium level. Okay, those with 0 stars are frame-based videos. And thanks to Fudan University and H. Zurich for providing them. For beginning to work, the frame-based features were transformed into a single representation using a bag of features approach. And we extracted a HMP feature. It's a histogram motion pattern. It tries to get a flow or continuity from the video. And we also used BOA. It's kind of similar to bag of features, but it's a bag of attributes. I will explain it, I think, next slide. Yes. To have a single representation from the features, we used the bag of features. It's really well-known information retrieval practice with the goal to summarize the data into one single representation. BOA is a similar method applied on machine learning as something like a feature transformation, where we consider the multiple representation as a new data set and each column a feature, where we apply a function on it. In our case, we used a maximum function for the CNN prob final layer. On the histogram of motion patterns, we extract a representation of continuity of the video, as I said before. I'm leaving the main references on the slide, so you can get more information if you want. So this is our approach. We mostly we get the inputs, make those transformations I mentioned, use rankers, learning to rank models, and then we try to aggregate the information as a late fusion approach. These are the models that we use for our learning to rank strategies. One detail that I personally like is about RankNet. It uses neural networks as a model for learning to rank, and I personally think that this would be a great exploitation idea. And these are the rank aggregation strategies. We have a border that it's a ranking position based, like it only considers the position of the video. The multiplicative approach, it's basically a geometric mean considering only the scores, and we try the weighted sum model, trying to get both information from rank and scores. Basically, we have in this step we have lots of rankings, new rankings. For video task, for example, we have 44 new rankings, and we try to, with these aggregation methods, we try to create one single final rank. These formulas indicate if they're considered only the score or position or both. One observation is that the position, we consider it reversed. So the last is number 1 and goes onto the left, and onto the first one in this case. So we have from a number of ranks, we created one single rank with each of the approaches. So we have 3 new ranks. And the number of rankers depends on what I will tell you later. This is the experimental protocol, just to tell you that we use the threefold cross validation method for the learning to rank models. Information that we already know about development and test data. And on the development data, we use only map to evaluate our approaches. And then the test set, we have the map 10. These are the configurations of our runs. On the fusion column, we have the fusion technique. We have image and video here. Run 1 does not use any fusion technique, so it's only a single feature ranker pair, so only one ranking. And on the next ones, we organized, for example, for video, we have those 44 new rankings, and we ordered them by the map value. And then we went from the best map value of ranker, and went aggregating new ones, as long as it make the result better, until we reached on the 3, 4, 5 runs for both subtasks, we got the maximum ranks that we got better values. Here are the results for development set. Thank you. We got for image weighted sum, got the best value for us on average map, and multiplicative approach with all the biggest aggregation got also the biggest value. And here are the test set. As expected, I run 3 for video, got the best result for map, but map 10 was close, but not that one, was run 5. And for image, we got a horrible surprise that we got our aggregation methods got worse results than a single feature result. So it was not a good surprise. Our remarks is for different. I think for fusion, mainly on video, it was a good practice to try to mix all the information. But for image, we were surprised, and we are not sure if it's kind of overfitting or maybe adding noise from the same source of information. And some future works, we think about, well, I personally think about working on raw data learning techniques, mostly like deep learning or neural networks, and maybe different strategies for selecting the feature ranker pairs. Thank you for the organizers of MediaEval and their supporters, AAAC and ACM Séjour, that would not be possible for me to be here without them. Thank you a lot.